Hey everybody, Jesse here for 3Prong Gaming, and in this episode we will get our AI moving to the building, I promise. So let's get this started so we can make sure we get it done, right? Alright, well in the last episode, what we did was we started building our behavior tree. And first, I want to apologize. I know I told you guys at the beginning of the last episode that we were going to have our AI moving, but I've really tried to want to do the best I can to explain this because, as I mentioned in the last video, AI is relatively complicated. It's easy once you start to learn it, but you got to learn it, and I want to try to teach you guys that. So if I don't explain something good, like I said, leave me comments. I will do what I can to explain to you one-on-one. So just let me know. I don't really want to move too fast through this. So this one, hopefully this should be a shorter episode. And again, I apologize for the last episode. It sucks seeing that on a Friday and then having to wait the entire weekend to get your AI moving, but hopefully it will be worth the wait. So what we need to do, let's jump right into this. We're in our behavior tree, our NPC behavior tree. We're just picking up right where we left off in the last episode. So what we need to do is go ahead and drag now off of your construction sequence, and we need to get a simple parallel. Now what a simple parallel does is you can see you got two different colors here. You got the purple and you got a gray right here. Now, if you equate this to the color of everything else, purple would be a task, while this kind of hooks up to another node, right? It doesn't have to be a composite node, but it just tells you it's hooking up to something else. So what it does is it runs this purple, whatever you have here, it will run this, and while this is running, this code is also running simultaneously. It's a simple parallel. It just runs both of them at the exact same time. So now I will explain why we're using this, is because this is what's actually going to cause our AI to move. All right. So we need to create a new task, even though there is, let me show you here, there is move. There is a move to right here that we can use, but we have no control over it. We need control. So most all the basic tasks and stuff that come default in the behavior tree, we're not going to use. We're going to create our own at some point or another. So move to is no exception. So go ahead and select new task. All right, and again, like I told you, we need to come in here and change the name of this. Like, do it right away so I don't forget. T underscore move to location. Hit enter. All right, so let's jump into here. So what we need to do for this, just like with the other one, since it's a task, we need to do a receive execute AI. Drop that in. So now, like we did in the last episode with our assigned work, we've got this reference cast right here. So just select it, push Control C, come back into here, push Control V, and it's going to paste it in here. Now it gives it an underscore 2. I just delete that and press enter, and good to go. Hook that up. Go ahead and plug this in. Now the problem with this is the only thing we have to do with this is go ahead and double click it. We don't have these variables, the pawn and the controller. So instead of going in and setting the type and everything, what you could do is just right click on here and create variable controller, create variable pawn. There we go. And it sets it up. You can see NPC BP and NPC AI controller. Perfect. It sets it up for us. We don't need to do anything else in that. Compile and save it. Make sure we got it. Okay. And now we need to add a few more variables. Let's call this one target location and make this one a key, a Blackboard key selector. Make sure it's editable. Create another one. We'll call this one destination. Same thing. Blackboard key selector, make it editable. And then the last one, we'll get our other one, which is current location and Blackboard key selector, make it editable. All right, compile and save it. So now we need to get our target location, drag it in here, get it. Now we need to get Blackboard value as vector. Okay, so now we're going to retrieve since in the last one, in the assigned work construction here, we set the Blackboard value to the value of the entrance of the proxy. Okay, so in our move to, now we're retrieving this, right? So we need to take our, well, let's just go ahead here. We need to do AI move to. Okay, select that one, drop it in here, plug it in. So now what this needs, it needs a pawn. So we take our pawn reference right here, drag it and drop it in there. Needs a destination. Well, we got that from our target location, so drag and drop it in there. Now this target actor, you don't need to use this one. This ultimately is, if we didn't have the vector, we could drop in, you know, like our destination. And our destination, we set that to the building proxy right here, right? We took, after we get our proxy, we take that and we set it into the destination. So really we could take that and plug the destination into target actor and not need this right here. However, it would move to the origin point of the building. Well, we set the entrance. He won't be able to get to the origin point of the building, and he will never succeed in his movement if we do that. So that's why we set the entrance point, and that's why we're doing this instead of setting target actor. The acceptance radius, this is if he gets within 5 centimeters of his destination, he'll call it good. Anywhere within there, that's the acceptable radius that you want him to move. 5 centimeters is default. I'm just leaving it there because it's okay. 5 centimeters, even in a 25%, well, in a 25% scale world, 25 centimeters would actually be what? Times that by 4. So it'd be 20 centimeters real world scale, you know, if you were to figure the scale. So we'll just leave it at that. It seems to be fine. All right. So what we need to do now is on success, what we need to do is we need to get our destination. Right. This is why we set this. It kind of seems weird and backwards, but it'll make sense as we move along. Our destination, right? This is the location we're moving to. We set that here, right? We set our destination to the building proxy. So because we want reference to that building right there. All right. So we take our destination and we get Blackboard value as object. Okay. So now we want to take this and we want to set it to our current location. We get it, set Blackboard value as object, plug that into the success. We only want to do this if the move succeeds. What these pins are is if your AI moves and he succeeds, if he gets to where he is going, this will execute. Okay, this right here, this will execute no matter what. If you want to run something off of these, off of here, then go ahead. But note that you could have problems. Try not to run a finish execute off of this because, yeah, you don't want him. You'll see in a minute. You don't want him to finish execution as soon as he moves. You want to wait until he succeeds or fails in his moves to do a finish execute. So pretty much everything I do is on success. All right. So now the current location, we need to set that to the destination. All right. Pretty simple. So now he succeeded. He's at the destination. So that's why we're setting that to his current location. And then we take destination again, get that. And now we need to clear Blackboard value. So now there is no destination. He's already there. So we need to clear this value out and make it null. So it is not set. So this is how you make your Blackboard keys, clear. You don't do, you know, in the past you just do set and you'd leave it as, you know, blank so it wouldn't do anything. But this is how you do it for the Blackboard, is just clear Blackboard value. Okay. And then after that, all we need to do is we need a finish execute. So drag off this, do finish execute. Now with this move to location, I'm making this as generic as possible. That's why we have target location. So that way we can reuse this particular node to move around the world. We don't have to rewrite this move to a bunch of times, you know, like move to the construction site or move to your house, right? We've just got one move to. All we'll do is we'll make tasks to assign the values to target location and destination, and then we'll pass those on into this. So whenever you can try to, just like with any function, you want to try to make it as scalable as possible and reusable as possible, so you're not wasting your time typing out. I mean, you can do tasks for every single little thing that you want, but if you have the opportunity to reuse something, or make it reusable, then do so. So on this finish execute, make sure it succeeds because we succeeded on our walk. Now, one thing's important here that we need to do. We need to take into account fail. All right, because he will fail. Like if you're walking, it took me a while to figure this one out. If he's walking through the world and you set your time, let me see if I can get this to play here. You set your time to 0 right here. Everything, when we set up his speed to be matched with this, he'll stop in the world, right? But the AI wants to continue to move, but he can't. So it'll see him as blocked. If you don't account for that being blocked, for you stopping the time right here, it will fail. You're going to have some issues. So we need to account for that. Okay. So, and not just that, we need to account for a couple other things as well. So what we need to do is off this move result, drag that out and type switch. We want to switch on ePath following results. All right, so now we need to change this. We don't want this to execute there. We only want it to execute on fail. If it fails, we get our movement results and we switch on it. Okay, so these are all the options for the movement results. We got success. Well, we don't need to worry about that because we've accounted for it there. We've got blocked. We've got off path, aborted, skipped, and invalid. Ultimately, what we need to do is blocked. Like I said, when you turn time to 0 and your NPC stops moving, once we hook his speed up to the game time, it will show as blocked. So all we need to do for this is just run this right back into the AI move like this. So if he shows up blocked, he's going to try to move again. If he fails, he's going to block again. So it's going to kind of create this infinite loop until you start time again. So that's what you want to do with that one. You can make an account for the rest of these if you want. I haven't ran into really any other issues, but what we'll do here is we go finish execute, right? And I did put aborted. I just plugged that in there, and then same thing with invalid. I haven't ran into either of these really yet. But we'll do that anyways because they seem like they may be common issues. If something's not right with your AI, just run like a print string off of this, and then run your code again, and when he fails, it'll say aborted or invalid or whatever your print string says. So, and if either of these happen, we want it to fail. So don't click succeed right there. And then that's it. That's our move to. There is one other thing we need to account for in this, and the way our AI, our behavior tree is going to be set up. If you saw, like I said, if you've seen my my teaser for the AI, I have a bunch of services, right? This is just a base branch to be able to get our AI to move to the construction site. We're going to handle construction and all that later. But with these services, we're going to have different AI states. We're going to have working. We're going to have sleeping. We're going to have eating. We're going to have looking for a house, things of that nature. So we're going to have a service up here that will actually switch these different branches. So if we're in the middle of working and he all of a sudden gets hungry, it's going to shut this cycle down completely. It's going to totally abort this and move on to the hungry, the hungry or the sleeping branch, whatever his new state is. It's going to switch to that. And if we're like in the middle of a move and it happens, we're going to have some problems. Okay, so we need to handle the abort in case it aborts. So go to your move to location. You don't always have to handle your abort, but it's important when you're actually moving, you need to handle your abort. So it's simple to do. Just right click and do receive. Oops, I spelled it wrong. Receive. You'll see receive abort AI. Go ahead and select that. All right, drop that in here. And now anything after this, if the service switches our branch, it'll automatically know it's an abort and it will run this code and execute it. So what we need to do here is drag off the controller. We do not need to cast this, right? That it passes the actual controller that comes through. The only time you need to cast is when you need reference from something out of that particular. See, we probably didn't need to do this. We could have probably just ran this pawn into here just fine and everything would have worked. Okay. But I didn't. So really, you probably, for what we have here, you could probably eliminate this whole thing, this whole casting, and just do that. But yeah, the only time you need cast is when you need something specific from that blueprint, from that instance of the blueprint. Okay, but we don't in this case. So go ahead and drag off the controller and just do stop movement. We want him to stop moving. That's it. All right. And then what we need to do now is, since he stopped moving and the state has moved on to another thing, what we need to do now is we need to take our target location, get it? We need to take our destination, get it? Take our current location, get it? And we need to do clear Blackboard values, right? Because whatever the branch switches to, Control W, whatever the branch switches to, it's going to reset these values for us. So if all of a sudden he's walking and he decides that he's hungry, then that new hunger branch will say, oh, well, you need to go to a restaurant. Let's set the target location to the restaurant. So it'll automatically set it for us. But we just need to clear out these values just to make sure that we don't get any conflicts with anything. So just go ahead and clear all those out. And then that's it. Type finish. We want the finish abort. And that's it. That will handle the abortion, for lack of a better word. It'll handle that when the time comes. So go ahead and compile and save that. So let's go back into the behavior tree, and off the simple parallel, drag off the purple one and type move to location. So there we go. We got that. And let's go ahead, and I forgot to do that again. Let's go to class defaults, node name. Let's move to location. So come back into here now, compile and save that. Come back into here and select and enter. There we go. Move to location. Trust me, try to set these names. You don't necessarily have to do it. We're not going to do it for all of these. We're not going to set the default name in there. But you know, this will be, and actually let's go ahead and rename this, not move to location. This is actually move to job site or construction site, something of that nature, because even though this is move to location, we're using it under here. So it'll make it easier if you make the node name something recognizable. So that way when your nodes or your tree gets really big, which it will, you can easily see, oh, this is move to job site. This is what he's doing, because you're going to have to follow through and follow the chain of events. All right. So now we got that. What we need to do now is we need to set those keys: target location to target location, destination to destination, and current location to current location. Save it. And when you save it, you'll see when you run a simple parallel, you have to have something off of this. It has to run something. So if you don't have anything running off when you save it, it's going to drop in an automatic wait node with a wait of 60 seconds. So we don't need that. So delete that. What we do need, though, is we need to check what this is going to do. Is this is going to make sure that, like, once we set up the ability to destroy a building, or even in this example, if he's walking to a construction site and the construction on the building completes before he actually gets there, this will stop his movement. Just like the abort, ultimately that's what it's going to do. Is it's going to handle the abort of his moving task. So this will run simultaneously, constantly checking to make sure that his destination is valid. And if it is, he'll continue to move. If not, we'll set a task here to stop that execution. So new task. Now that we have several tasks made, now when we click new tasks, we get an option here. So we can actually make like a child of the assigned work construction. But for the most thing, just keep it at BTT task blueprint base. We want the base. All right. So jump in here. I'm going to rename this. Do F2 T underscore stop movement. Hit enter. All right. Let's go back into here. Receive execute AI. And we don't need to run any node, any references off of this. So drag off the controller, just like we did on the abort for the move to. We're going to do stop movement. Okay, and stopping movement, what we need to do now is if he's moving, doesn't have a current location set, so we're not going to worry about that, but we need to do a target location make it a Blackboard key selector, editable, and create a new variable, destination, and make it editable, Blackboard key selector. So now we just need to clear these out, get it, clear Blackboard value, right? And then Control W, drop that in there as well, plug that in, and tidy all this up a little bit, and then hook your destination up to this one, get it, and plug it into there, right? And then that's it. So now we need to finish execute. And since we're stopping movement, once all this happens, we want it to succeed, okay? Compile and save it. So this will help handle, like I said, if our destination ends up getting destroyed, it will run this execution. So let's go ahead and set that up. So how do we set that up? We drag off of here. We do stop movement. And hold on, before I do that, let's go up here, set defaults, set this to stop movement as the default node name. Compile and save it, back into here, drag it out, stop movement. So now we got automatically stop movement in there. Target location, we need to set those key values to target location. Destination will be destination. All right, save that. So now the problem with this, the way we have this set up, is this is automatically going to run side by side with this. So this, as soon as we start to move, he's going to stop moving. So we need a way to handle that, right? So we do things which are called decorators, right? Decorators are conditional checks. It's kind of like running a branch. Okay, so think of it that way. It's just a condition check. So what we need to do, it's got a bunch of default decorators. You right click on the purple and add decorator, and you've got these in here. Some of them we'll use, some of them we won't. For the most part, we're going to create a lot of our own, but what we're going to use here is we're going to use a loop. Okay, and it defaults to a loop of 3. We actually want to make this, select the loop, come over here. You can set a number of loops that you want, but for this particular task, because we don't know how long it's going to take him to get to the job site, so we want to run an infinite loop. You get an option right here, infinite loop. So it's going to run continuously until either he succeeds right here and passes a simple parallel, or the next condition. Now, this is still going to run stop movement, and it'll succeed and it'll move on. So this loop it'll run once and hit stop movement. So then we need to create a custom decorator now. All right, select that. And this is done a little bit different than, let's go ahead and do D underscore does location exist. Right, I think that's what I named it there. I did destination, I named it differently, but does location exist? Go ahead and jump into here, and I did it with a D because it's a decorator. All right, now these are a little bit different, right? Instead of doing receive execute, even though you have some options here for receive execution, we don't want to do that. Decorators, all you really need for a decorator is if you click functions in here under override, you're going to see perform condition check AI, because this is all that's really done for decorators. Is we're just running this, we're going to pass true or false. Did it, like I said, it's a conditional check. Did it pass or did it fail? All right, so with that, what we need to do is we need to create a new variable here and call it destination, and we will set it to a Blackboard key selector, make it editable, and go ahead and drag this in, get Blackboard value as object, and drag this out as is valid, just the function right here, and then it conveniently gives us a true or false. Is it valid? Plug it in there. All right, so now we can handle it that way. Now, we could have used a default decorator for this, but I really don't like to. I like to have a little bit more control over this, because we change, as long as we're consistent with setting and clearing this value, we should be good to go. Because we could have really went right click, add decorator, and used the Blackboard right here, and then checked is destination right here. You select destination, is destination set? All right, well, in this case, we'd actually have to inverse it, so we have to make sure it's not set. But you have the option. We could have did that, but like I said, I'd rather have my own. So just right click, add decorator. We did our D, does location exist? So there it is. So now this will tell us, is this object valid, right? Is the building still there? Because see, our destination could still be there if once the construction completes, but we need to know, because the original object we set in here will be the construction proxy. So if the construction proxy finishes before he gets there, then the construction proxy destroys itself. So this is no longer a valid key. There still may be a value in here as far as the Blackboard is concerned, but the object that was in there is no longer valid. So that's a lot of the reason why I did that. So select the decorator, right? We need to change destination here to destination. And boy, we're at 25 minutes already. I thought this was going to be a little bit shorter. So the node name, let's just call this does destination exist. All right. So again, this will still run because it's going to loop. It's going to say, does this exist? Well, yeah, of course it exists. We're moving to it. All right. So what we need to do, we need to actually come over here and select inverse condition. So this, even though, we want it to be true. We want it to be true to run this. All we're checking to stop movement is if it's no longer good. So remember, we're passing is valid. If it is valid, then it's true. Well, we only want to handle this if it's false. So that's where you inverse it at right there. Okay, so just select it, select inverse. And that is it. Now we should be able to get our AI to move. Actually, no, that is not quite it. Go into your NPC AI controller. Other thing we need to do here is just drag off of the begin play. We need to use Blackboard. Select that. And then we need to tell it which Blackboard to use, which is the NPC BB Blackboard we made. And then drag off of this and do run behavior tree right there. Now select the behavior tree that we want. Again, this is in the AI controller. You don't have access to these in the actual NPC blueprint. So it's got to be in the controller. And then one last thing I want to do real quick, even though we don't need it in this episode, let's go ahead and right click. Let's go possess. Oops, I spelled it wrong. I did spell it wrong. Possess. Event on possess. What this is going to do is when this controller possesses a pawn, let's just do pawn reference. And at begin play, it actually won't have control of the pawn. Okay, so we can't do like we did with our camera pawn or most anything else where we right off begin play, we get all our reference cast. That doesn't happen with here. Begin play happens before it actually takes over the pawn. So what we need to do with this is now we need to drag this out, set it to the possessed pawn right there. Okay. Oops, we didn't set that. Not the camera pawn controller. We need to set that to NPC BP reference. Yes, change variable type. No, get out of my face. All right. Now with that, now we can just drag this in and no, we can't. Possess pawn. Compile it. Oh, because we got to cast it. Wow. Okay. Cast. Sorry about that. Cast to NPC BP. Make this the pure cast. Now, there we go. That works. Silly mistake, silly mistake. All right. So now we got that. We'll need that in the near future, but I just want to do it here because it was, well, it was supposed to be simple and quick, but yeah, leave it to me to screw that up. All right, so that's it. So now we should be able to move. We're using our behavior tree, running our behavior tree. So let's jump into the world right here. Actually, let's go back into here just so it doesn't, I don't like doing it in here because it plays in the editor. I'd rather have a separate pop-out window. So click play. So there we are. Press V to drop in our first NPC. Now they're not doing anything. So let's go over here real quick and let's minimize this window a little bit. Go into our behavior tree. All right, you can see it's debugging for our NPC in here already. All right, so what's going on? It's coming in here, it's hitting the wait, and then it's going to assign work. Well, assign work's not succeeding because, well, there's no work. We have no construction proxy. Okay, because if you remember in here, we can set the debug into here. Right, I don't know which one it is. But yeah, see, so it's automatically failing because it's not finding anything in the proxy. So it's coming in, and it's failing every single time. So jump back into the behavior tree, come over here. So now we select, let's just select a construction office, put it out here somewhere. Bam. Now they run there. Boom. We succeeded. Now we're there. Sweet. So it moves. So now we could do another one, but problem is they won't run. Remember, they're only accepting the first one, which for the most part is okay because they're here, they're doing construction on this one. We're going to set up the construction. So once this is built, they'll be able to see this one. This one will now become index 0, and then they'll run to that one. So yeah, that's it. Empty out of that. Let's try that again here. Oops. Just because it's cool and we can. Go back to the behavior tree. Press V. They're just going to... Where did I drop that person? Oh, I dropped him inside the building. That was kind of silly. We'll do that. We'll drop a couple in here. Right? And they're all going to run to this. Now we still got to see how the random weight, they don't all run at the exact same time. And they're not supposed to be running into this. I don't understand why. He just ran into my sphere. What is up with that? See, he's waiting. Oh, dang. He ran into that sphere. That sphere is not supposed to have any collisions. I don't understand why I'm still having issues with that. All right. I'm going to have to look into that off camera. So 31 minutes, almost 32 minutes. Took a little bit longer than I had expected. But yeah, I kind of took my time with it and explained it to you. And now you see why I didn't have enough time in the last episode. Because I really don't think I wasted any time in this one. As always, I hope you guys enjoyed this video. If you did, please do me a favor. Go down and hit that like button. It really does help me out. Like. It helps me out. Gets me some exposure and gets me seeing YouTube's algorithms use the likes and the comments. Use that down there. Give me a comment. Let me know what you thought. Check out one of those other videos that are playing on the screen. If you're new to the channel, go down and subscribe. And until next time, peace.